Today, we're diving into a new NVIDIA architecture that could seriously change the game for AI speed. It's called TiDAR, and it's all about tackling one of the biggest bottlenecks holding language models back. So let's get right into it. The big problem in AI generation right now is this constant trade-off. On one side, you've got the genius. These are your autoregressive models like GPT. They think really carefully, giving you one perfect word or token at a time. The quality, amazing. The speed, not so much. On the other side, you've got the drafter. These are diffusion models that just blast out a bunch of ideas all at once. They're super fast, but yeah, the quality can be a little rough around the edges. So let's break that down a bit. Diffusion models are kind of like a creative speechwriter who's brainstorming. They aren't writing the speech from start to finish. Nope. They're just throwing a whole bunch of ideas and potential future words onto the page, all at the same time. This parallel thinking is what makes them so quick, but it doesn't always have that perfect polished flow of a final speech. And then you've got your auto-regressive models. Think of these as the meticulous speaker. They take the speechwriter's best idea and deliver it flawlessly, one word at a time. They're making absolutely sure that every single word follows logically from the last. This gives you that top-tier quality and coherence, but generating a long answer this way, it's a total memory-bound, token-by-token slog. So this brings us to a really crucial idea, a quote from the NVIDIA researchers themselves. Think in diffusion, talk in autoregression. What if you didn't have to pick one? You know? What if a model could actually combine the lightning-fast brainstorming of the speechwriter with the perfect delivery of the speaker? And that right there is exactly what NVIDIA's TiDAR architecture is all about. It's a hybrid built from the ground up to give you the speed of diffusion and the quality of autoregression, the best of both worlds. The real breakthrough here comes from a really simple but super powerful hardware insights. See, when a GPU has to process a token, most of the time is spent just loading the model's weights from memory. So processing a few extra tokens in that same go barely adds any time at all. These are what they call free token slots. It's basically just unused computational power that's sitting right there. And this is the absolute core of the innovation. TiDAR uses those free slots to do both the drafting and the verifying simultaneously. This isn't a two-step process where you draft and then you check. Nope, it all happens in one single computational step. A single forward pass that does everything at once. So here's what's happening inside that single pass. You've got the autoregressive part acting as the verifier, making sure the text that was just generated is top-notch. And at the exact same time, the diffusion part is already brainstorming, drafting multiple options for what to say next. It's this concurrent thinking and talking that makes it so ridiculously efficient. Now, how do they pull this off? Well, it's all managed by a super clever trick called a structured attention mask. Just think of it like a set of instructions for the model. It splits up the sequence and says, all right, for these prefix tokens, I want you to act like a careful speaker. Only pay attention to what came before. But for these new draft tokens, I want you to be a creative speechwriter. Look forwards and backwards to come up with brand new ideas. This is what lets both modes run in the same model in the same pass. Pretty neat, right? Okay, so the theory is really elegant. It sounds great on paper, but does this thing actually work in practice? Let's take a look at the numbers. And here's the payoff. For an 8 billion parameter model, TiDAR gets a staggering 5.91 times speedup in throughput compared to its purely autoregressive cousin. We're not talking about a small improvement here. This is a massive leap forward in how many tokens you can generate per second. I mean, just look at this chart. When you see the raw tokens per second, the difference is just, it's not even close. The baseline model is chugging along down here, and TiDAR is way, way up here. That's the kind of jump that takes a user experience from laggy and frustrating to feeling almost instantaneous. Okay, so it's faster, a lot faster. We get it, but that's only half the story, right? The really big question is it still smart? Do they have to sacrifice the genius to get that speed? What's the catch? And the data shows there is almost no trade-off at all. Just look at these benchmarks for the 8B models. On GSM 8K, which is a really tough math reasoning test, the scores are practically identical. Same thing for MLLU, which tests broad knowledge. Okay, yeah, there's a slight drop on the coding test, but overall, TiDAR is delivering basically the same quality at nearly 6 times the speed. It's also really important to understand that this is totally different from other methods like speculative decoding. Those still work in sequence. A small model drafts, then a big model verifies. Draft, verify. Draft, verify. It's a chain. TiDAR's big innovation is making those two things happen in parallel. The drafting and the verifying are happening at the exact same time. So to wrap this all up, what's the big takeaway? Well, hybrid models like TiDAR are solving that age-old speed versus quality problem. By making thinking and talking happen in one single step, they're taking advantage of that free compute power that's just sitting there on modern GPUs. And the result? A massive 4 to 6x speedup with almost zero hit to quality. You know, this breakthrough isn't just some academic paper. This gets us so much closer to a future where we can interact with AI in true real time. So the final question this whole thing leaves us with is, could this be it? Could this be the key that finally unlocks those zero latency AI assistants that can think and talk just as fast as we can?